Today, I'm going to show you just about every tool, technique, and material that you can use with your ShopBot CNC machine to make beautiful work. First, I'll show you all the examples, and then we'll dive into each one. Check these out. Hey. Let's kick off this series by making a thick block of epoxy resin mixed with a bunch of kiln-dried cedar tree branches from my backyard. After it cures, we'll take it over to the ShopBot and flatten one side. We're using a surfacing bit with a 1-inch cutting diameter. It transforms my ShopBot into a 24-inch wide planer. When that's finished, we'll swap out the surfacing bit for an upcut spiral O-flute and begin cutting out our letter. When milling epoxy resin, the chips get really hot. This bit evacuates chips quickly to avoid melting our material. And so this is what it looks like when it's all finished. You could also use colored pencils or just keep it pure. B. You can work with a lot of different materials using a ShopBot CNC machine. And today, we're going to focus on cutting aluminum and other non-ferrous metals. To do this, we're going to use an upcut spiral O-flute with a short cutting diameter to minimize any chattering. I'm also using a mist lubricant system hooked into my air compressor to help cool my bit and to evacuate my chips. When milling aluminum, the chips get really hot and they have a tendency to want to stick to the tool. The misting system paired with the spiral O-flute prevents this from happening. Cutting aluminum is easy as long as you use the right bit, you keep it cool, you evacuate your chips, and you use the correct feeds and speeds. And when it's all finished, milled aluminum looks fantastic. And brass looks great too. C. Okay, for this one, we're going to use high density urethane, or HDU. This stuff carves beautifully. However, the real star of the show is this enormous 130 degree V bit. And we're going to pair it with the prism carving toolpath. Now the prism carving toolpath is like a V carve, except that it's inverted, and the apex at the center of the letter is raised. Okay, so now we're going to swap out that bit for a 1/4 inch upcut bit and finish cutting out the rest of the letter. And finally, we're going to prime it, paint it, and finish it. D. Just for fun, let's make our own plywood. To do that, we'll resaw some lumber, put our boards through the drum sander, glue them up along with a few dyed veneers, throw them in a vacuum bag, and the next day, I've got my plywood. Now to cut out our letter, we're using a compression bit. A compression bit is designed to work with laminated materials like plywood. It has both upcut and downcut sections that prevent the plywood's top and bottom veneers from chipping. To avoid chip out on the top veneer, we also need to use a lead-in and make our first pass depth 0.3 inches deep so that the upcut portion of the compression bit is below the top veneer when we begin cutting our letter. But if all goes well, we don't even need to sand the letter when it's finished. E. The ShopBot is more than capable of working with leather. Let's use some double-sided tape to adhere our veg tan leather to the spoil board. We're using a 2mm drill bit paired with an adapter to create the stitching holes for our letter. Each hole is spaced 5mm apart, similar to what you'd find if you used a traditional all-stitching chisel. Now, let's swap out our drill bit with a drag knife. A drag knife is basically a pivoting razor blade, but for this one, remember to turn off your spindle. Also, the drag knife gadget in VCarve Pro makes it simple to create the perfect cutting toolpath. And after a bit of stitching, burnishing, and oiling, here's the final result. F. Let's use AI to generate a few images. We're looking for a woodcut lowercase f with skulls and roses. Well, it's not quite lowercase, but we can manipulate it, turn it to a vector, and mirror it. And if you haven't guessed, we're making a black and white lino cut. I'm using a 30-degree V-bit to carve our graphic into our linoleum block. It has a flat depth of 0.05 inches. Now let's swap out the V-bit for an end mill and cut out the profile of our letter. A lino cut doesn't have the same resolution as a photograph. It's more like a big stamp. When that's finished, we're going to apply some ink, roll it onto our stamp, and then we're going to put it through an etching press. I don't have one, so I'm sort of improvising here using a cold laminator instead. Finally, we'll reveal our image. G. We're going to use our ShopBot CNC machine to make a reusable mold. Let's start out by creating the shapes needed to make our letter and the container for our form. I'm using a dust boot as cutting MDF makes a lot of dust. When that's finished, let's glue up our letter to make it a little thicker, and then we're going to prime it and apply some shellac. Next, let's create the outer container. To make our mold, let's mix it up and place it in the vacuum chamber to remove any bubbles. And now we're ready to pour it. And after waiting a day, well, we finally have our mold, and it looks perfect. For our first casting, let's try concrete, but it's important to know that you can cast lots of different materials. Concrete looks really good. You can also use resin or even soap. H. Let's start by ripping some maple, white oak, and walnut into strips. And then we'll glue them up to make some wood that looks like plaid. Now let's use our ShopBot CNC machine to cut out a reusable acrylic router template. A router template allows us to create repeatable shapes using simple tools. Next, let's position our letter exactly where we want it and trace the entire thing. Now we'll fire up the bandsaw and cut slightly outside of our trace line. It's all cut out, so we'll use some double-sided tape to temporarily adhere the router template to the letter. Almost done. Finally, shave off any excess material using a flush trim bit or pattern bit on your router. This will make our letter exactly the same shape as our router template. I'm writing some code that generates a grid of random triangles. Let's run the script and etch the vector it produces onto a pane of glass. But first, I'm going to mark the size of the glass pane onto the spoil board. Then we'll apply some double-sided tape and adhere the glass pane to that exact spot. This way, my etching will be right where it needs to be. We're using a diamond drag bit to etch the glass. If you zoom in closely, you can actually see the diamond. Next, let's turn off the spindle and create a quick engraving toolpath using VCarve Pro. This spring-loaded diamond drag bit can etch things like metal, stone, and plastic. And of course, it also etches glass beautifully. Sounds neat too. So let's finish up by etching the outline, cleaning it up a bit, and then illuminating our code-generated graphic. J. Let's start this one by making 64 thin strips of wood. We're going to use them to make a bent lamination. We're using a ShopBot CNC machine to create a two-part form. The idea is to glue up our thin strips of wood between the two parts to achieve a perfect curve. In fact, I used a CNC machine to create 4 different curves to make the glue-up more manageable. More on that later. Add some tape and finish our form. Now we're going to glue up 16 strips at a time and place them into our form. Clamp everything up and let this sit overnight to ensure that the wood holds its shape. As I mentioned earlier, I glued these up in 4 separate passes. This is the first one. And here are all 4. The ShopBot made it extremely easy to create the unique curves needed for each glue up. And after a bit of cleanup, well, here's the final result. Okay, we're going to make a circuit board. Let's start out by laying out our circuit in fritzing, making our traces, and generating our G-code using FlatCam and OpenSBP. Next, we'll tape our blank down to our spoil board and insert a 30-degree V-bit into the collet. The V-bit's sharp point allows us to make tiny traces onto our circuit board blank. And when that's finished, we'll swap that out for a really tiny end mill to drill the holes out for the LEDs. And then we're going to use the same bit to cut out the profile of our letter. So far, it looks great. Now all we have to do is prime, paint the front, insert our LEDs, and solder them onto our circuit board. And once we plug everything in, well, it lights right up. L. My friend is renovating an old home, and he asked me to recreate this original molding. So I traced the profile of the molding and used the molding toolpath in VCarve Pro to create the form. And in just a few clicks, we have the perfect toolpath. When carving 3D forms, it's best to use a ball nose milling bit. We'll start by removing the bulk of the material using a few rough passes. We don't want to be too aggressive as we risk splintering our wood and ruining our piece. Fortunately, the molding toolpath takes care of all of this. Next, we'll run our finishing pass. And then, we'll cut out the outline using a 1/4 inch upcut spiral end mill. And as expected, well, it looks just like the original molding. Now, let's just finish it up by applying a coat of primer and paint. L. M. We'll start by painting some PVC and applying some masking. This will allow us to make a 2-color V-carve. To cut our pattern, we're using a 90-degree V-bit. We're going to pair that with a V-carve engraving toolpath. The deeper the bit plunges, the wider our line. PVC is easy to carve and can withstand the outdoor elements, making it a perfect material for making signs. Next, we're going to use a 1/4 inch upcut end mill to cut out the profile of our letter. And when that's finished, we'll remove the tabs using a flush trim bit. Now we'll apply our second color. The masking we applied earlier protects the darker paint underneath. Once we peel off our masking, well, we'll have a detailed 2-color V-carve with crisp edges. N. Let's create an inlay. We're going to start by making 2 end grain blanks. We'll make our pocket out of maple and our plug out of walnut. Next, let's grab a 60-degree V-bit and begin carving out our plug. To speed things up, we'll clear out the larger areas with a 1/4 inch end mill. Now let's carve out our pocket using the same V-bit. And when that's done, we can cut out the profile of our letter. With our plug and pocket finished, it's ready for our glue up. And if all goes well, the plug should fit snugly inside of our pocket. When the glue dries, we cut off the excess material and hope for no gaps. Awesome. Next, we'll clean things up with a bit of sanding, and now we've got a perfect inlay. O. For this letter, we're going to create an inlay that goes all the way through our material. It'll sort of look like this, with each piece fitting snugly into place. To do this, we're going to use the inlay toolpath. We'll start by cutting out the inserts out of Padauk, Teak, and Yellow Heart hardwood. And when that's finished, we'll use the inlay toolpath again to cut out a few holes in a glued up maple panel. The inlay toolpath compensates for the tool radius by rounding off sharp corners, allowing each insert to fit into each hole. Now we'll move on to our second set, and then finally our third. Almost done. With our panel all glued up, let's finish it up by cutting out the profile of our letter. P. Let's explore what we can do using a plotter pen with our ShopBot CNC machine. To set things up, we'll insert a mini Sharpie into the bottom of the shaft and a weight into the top. The weight applies pressure on the top of the pen to help us to achieve a consistent mark when drawing. We'll make our cut depth 0.15 inches and make sure that we're drawing on the line. Before running our job, remember to turn off the spindle. The plotter pen simply follows each line until our entire drawing is finished. Drawing using a CNC machine is surprisingly simple and satisfying, and the pen itself, well, is relatively inexpensive. Now you can create a simple drawing like our letter P, or draw more complicated designs like this one. Q. Today, let's make a lithophane out of Corian. We'll need 3 bits, an 1/8 inch ball nose, a 16th inch ball nose, and a 1/4 inch end mill. I'm using a spire to carve out our lithophane. Our photograph will emerge when backlit. Let's start with a 3D roughing toolpath to remove the bulk of our material using an 1/8 inch ball nose. For our 3D finishing toolpath, we'll use a 16th inch ball nose. And then, we'll cut out the profile of our letter using a 1/4 inch end mill. I also created a walnut backer to house our LED lighting strip. And finally, let's glue it up and see how it looks. R. For this one, we're going to carve soapstone. Soapstone is a naturally occurring metamorphic rock that can be easily carved using a ShopBot CNC machine. I downloaded a 3D model of the moon from NASA's website and brought it into Aspire for tooling. We'll start by using a 3D roughing toolpath to remove the bulk of the material using an 1/8 inch ball nose bit. Despite being stone, this material is incredibly easy to work with. With the roughing toolpath finished, let's start our 3D finishing toolpath using the same bit. During the finishing pass, you'll see each crater emerge in perfect detail. For the smaller craters, we'll use a 16th inch ball nose bit. And now, we'll finish it up by cutting out the profile of our letter. S. Today, working with a sheet of two-tone HDPE, or high-density polyethylene. To hold our piece down, I'm using a portable vacuum system developed by Airways. This means no hold-down screws or tabs. We'll be using an 1/8 inch end mill for both our pocket and profile toolpaths. First, we'll carve out our zebra stripes, and then we'll cut out our letter. HDPE is a lightweight, durable plastic that is resistant to UV radiation, can withstand harsh weather conditions. It's also incredibly easy to mill using a ShopBot CNC machine. We'll finish this up by cutting out the profile of our letter, turning off our vacuum system, and admiring our work. T. Let's make an inlay using some black Corian and mother of pearl. We'll be using this tiny 16th inch end mill for most of our project. Let's start by cutting out the pockets out of our black Corian. And then we're going to cut the profile of our letter using a 1/4 inch end mill. Next, we'll use this template that I created on the ShopBot to help us batch out 25 tiles at a time. Apply a dab of CA glue and affix a tile to each square. Mother of pearl is surprisingly easy to cut using our tiny end mill.
I use the same bit for all 106 tiles. Then, let's drench each template in acetone to help loosen the CA glue. And once you glue in all the pieces and clean things up, well, G10 is a high-pressure fiberglass laminate. It's the most abrasive material that I've ever worked with. We're using it to create a simple letter, but with a twist. For this one, we'll need a mask and adequate dust collection. This stuff is nasty, tough as nails, and it loves to eat bits. And as promised, well, here's the twist. Let's scan our clay model using this fancy 3D scanner that I'm borrowing from my friend John. Then, we'll bring our scan into Aspire for some double-sided milling. When that side is done, we'll flip it over using the dowel method and then attack the other side. I'm using a 16th inch ball nose bit and a finishing toolpath to carve the twist. And now, we'll slice it up, glue up the pieces, sand it, and then do some sculpting to blend it all together. V. It works! Let's have a little fun with this one. We'll start by cutting some EVA foam on our ShopBot using a 1/4 inch downcut end mill, using a conventional cutting technique for a nice clean cut. We're cutting pockets to house a number of electronic components. These include an Arduino, a flex sensor, an accelerometer, an MP3 shield, and a speaker. I'm also using an Airweights vacuum table to help us achieve a nice clean profile. Now we'll do a lot of soldering, and then we'll write some code to trigger a few sound clips. We'll finish things up by pushing our components snugly into place and adding some googly eyes. W. Let's start this one by making a quick doodle using Procreate. We're making a magnetic puzzle. For the hold down, we're going to affix some painter's tape to our spoil board and apply some CA glue. Then, we'll add more painter's tape to our magnetic sheet and apply some activator. This will hold down our magnetic sheet and allow us to cut out our puzzle pieces without using any tabs. These 60mm magnetic sheets cut beautifully on a ShopBot CNC machine. I mean, look at those chips, they're gorgeous. I'm using a 16th inch end mill with a slight offset to ensure that our pieces fit together perfectly. When that's done, we'll peel up our puzzle pieces and do a quick dry fit to make sure that everything looks okay. Now we'll use a UV printer to print our doodle onto our sheet. And then we'll assemble our magnetic puzzle onto a whiteboard. X. This is die bond. It has a polyethylene core sandwiched between two thin sheets of aluminum. One side is white and the other side is metallic. While die bond is typically used to make signage, we'll be using it to create a multi-layered design. I'm using a 16th inch end mill to cut out our shapes. Die bond cuts beautifully on a ShopBot CNC machine, producing clean, crisp edges. It's also inexpensive, lightweight, rigid, and weather resistant. And obviously, it won't dull your cutting tools nearly as quickly as milling solid aluminum. Now that our 4 layers are cut out, it's time to do our glue up. And here is the final result. To wrap things up, let's add a bit of projection mapping to bring our design to life. Why? Today, we are going to carve ice. To create a clear block, we'll use distilled water and place it in a vacuum chamber to remove any air bubbles. The key is to freeze it slowly, ideally at 30 degrees Fahrenheit, over 2 days. Once the block is ready, let's secure it down, although using clamps may have been a better option. Carving ice is surprisingly simple, although you may need to use compressed air to blow away any ice chips before they refreeze. After 3 attempts, I finally have a beautiful block of carved ice. I also milled several acrylic snowflakes and created a silicone mold. I added some blue food coloring and allowed the snowflakes to freeze. Finally, we'll attach the blue snowflakes to our clear block. Z.
Ready? Come on.
Today, I'm working with Jimmy Diresta. We're making a table out of composite decking material. We're using an 1/8" milling bit to create some funky joinery that Jimmy cooked up. Composite decking, made from recycled materials, cuts beautifully on a ShopBot CNC machine. Now we'll use a 90-degree V-bit to carve the ShopBot logo on the top of the table. We'll trim things up, and then we'll add a few countersinks and assemble all the pieces. Honestly, working with Jimmy to shop was the highlight of my year, and it feels like the perfect way to conclude this series. So thank you, Jimmy, and thank you, ShopBot. So I hope you enjoyed the series, and if you have any other questions, please let me know. I'm always happy to help.